Okay, so for A, actually once you have A and C, I'll just redraw the triangle. So you have 15, A, and 16.83. You can use the Pythagorean theorem. Or if you wanted to, you can do the same thing we did for angle C, but just do it with sine. Or use sine of 27 degrees, which is equal to opposite over hypotenuse. So sine of 27 degrees is equal to A over 15. Okay. So if we multiply, not A over 15, A over 16.83. Sorry about that. Okay. So that means our A is equal to 16.83 times sine of 27 degrees, which for some odd reason I didn't calculate. But this part you just plug into the calculator. Thought I did that already. I guess I got to do that part. All right. So any questions on that one? All right. There's actually one thing I wanted to make sure I showed you. I know I wrote it out. I don't know why I can't find it. Well, I'll figure it. I think I have it memorized well enough. Okay. So we can actually use a right triangle for that entire list of angles and sine of theta is this and cosine of theta is that. You don't have to memorize those. So here's a shortcut method to memorizing those. Okay, so let's see, start off with a triangle. Each side is length of 2. Okay, so if we get that triangle and just cut it right down the middle. So if it all angles of or all sides of 2, that means the angles are all 60 degrees, or pi over 3. Okay, so if you get this and you cut it right down the middle, then that means instead of 2, this becomes 1 on this side and 1 on this side. Oh, too high. There we go. And this pi over 3 is cut in half. So pi over 3 divided by 2 just becomes pi over 6. So it's pi over 6 and pi over 6. So we really only need one side, because as soon as we cut it down the middle, we created a right angle. Okay, so we now have the right triangle. This is our right. This is 1. This is 2. And if we use the Pythagorean theorem, this would be square root of 3. Remember, this pi over 3 was cut in half. So that became pi over 6. And this is pi over 3. Okay, so if we want to find sine of pi over 3, remember that's opposite over hypotenuse, square root of 3 over 2. If we want to find tangent of pi over 6, remember that's opposite over adjacent. Opposite over adjacent, 1 over square root of 3. If we rationalize it by multiplying them both by square root of 3 over square root of 3, you get square root of 3 over 3. So that entire list can basically be simplified with that, at least the pi over 3 and pi over 6. The pi over 4 actually has a different way to measure. And you can do this the same thing with angles, with degrees. but instead you'd start off with 60, 60, 60. It's still 2, and you cut it in half, so that 60 will become 30 on each side. So you have a 30, 60, 90 triangle with 1, 2, square root of 3. So it's the same thing, you're just changing it up a little bit. So this is degrees. Clean that up a little. Okay, so let's say if you want to find secant of pi over 6. First thing you do is find cosine of pi over 6, and then flip it. So cosine pi over 6, which is adjacent over hypotenuse, so square root of 3 over 2. So that means secant of pi over 6 is just 2 over square root of 3. Uh-oh. Which, if we rationalize the denominator, is 2 square root of 3 over 3. That over there. Okay. So if you can draw that triangle, you don't have to remember that entire list. You don't have to do the square root of 4 over 2, square root of 3 over 2. You don't have to do all of that. You can just go right to this triangle, at least for your pi over 3 and pi over 6. All right. Any questions on that one? Yeah. Oh, when we cut this one in half, we had the 1 and the 2. So we had our a squared plus b squared equals c squared. So if this was our side b, that gave us b squared equals c squared minus a squared. So our c is equal to 2. So 2 squared minus our a is equal to 1. So our b squared is equal to 4 minus 1, which is 3. So if we square root both sides, we have b equals square root of 3. All right. Does that make sense? Okay. All right. Any questions on this one? All right. And if you wanted to, you can actually do this same thing for all 4 quadrants. Because remember, everything we did here was for quadrant 1. So this would be 1, 2, square root of 3. But let's say if we want to do that for quadrant 3. Okay. Our x would still be 1. Our y would still be square root of 3. And our radius would still be 2, our hypotenuse, because this is our theta. The only difference is here, our x and y are negative. So this would be negative 1, negative square root of 3. And you do the same SOHCAHTOA and flipping everything else. So you can do it in any quadrant. Right. Any questions on that one? Okay. Like I said, this is just the find for the pi over 3 and pi over 6. And I'll write that at the top. Find pi over 3 and pi over 6 trigonometric values. Okay. Now the only difference for pi over 4 is that instead of having a triangle where it's 1, 1, 1, I mean 2, 2, 2, it'll be 1, 1, 1. All right, so that one is actually, I'm trying to make sure I'm doing it the right way. I'm going off memory. Oh, anyone still writing this one? Oh, I'll leave that up there. All right. sure I got that so I don't tell you the wrong info. Now, okay, now I remember. This one you don't start off with a triangle. You start off with a rectangle. That should be a neater looking rectangle. Okay. So we know for this rectangle, all sides are 90 degrees. Okay, and we have each side a length of 1. Okay. Now if we get this rectangle and we cut it in half, we only need one of them, so we can kind of get rid of that one, which leaves us with this rectangle here. We have a side of 1, side of 1. This is a right angle. This right angle was cut in half. So instead of 90 degrees or pi over, instead of pi over 2, it's now pi over 4. And this one, same thing. It's cut in half, so that pi over 2 became pi over 4. Okay, so use the Pythagorean theorem. You have 1 and 1 here. You can figure out your hypotenuse would end up being square root of 2. Okay, so hypotenuse found using Pythagorean theorem. Oh, there we go. All right. So from there, let's say if we have sine of pi over 4. That's opposite over hypotenuse. So I have 1 over square root of 2. If you rationalize that denominator, you have your square root of 2 over 2. Okay, so what if we tangent of pi over 4? Which is opposite over adjacent, which is 1 over 1, which is just 1. And you can match all of these up with your chart, and it'll be the exact same. So that big old chart, you don't need it. Okay, and it's the same thing for degrees. But for degrees, it'd be 1, 1, square root of 2. What would be 45, 45 degrees, and 90? Okay. So since these are both 45 or both pi over 4, it doesn't matter which one you use. All right. So any questions on that one? All right. And this is to find the pi over 4 trig values. Okay. So to kind of summarize it, I'll summarize it on another sheet. Oh, anyone's still writing? Go bring that up some. Right. Just sort of kind of summarize it all onto one sheet. Oh, sure I don't miss anything. You have 1, square root of 3, and 2. You have pi over 6, pi over 3. Or you can have that same, that's kind of a odd looking right triangle. But You have 1 square root of 3 and 2 of 60 degrees, 30 degrees, 90 degrees. Okay, so this is for your pi over 3, pi over 6, or 30 and 60 degree values, or trig values. Okay, so even if you just remembered one of these, you can convert the pi over 6 to 30 degrees. And for the (45-degree) angle, 45 degrees, well, I'll keep them lined up. Pi over 4, pi over 4, and that would be 1, 1, square root of 2, or you have a right angle here, 45, 45, and you have your 1, 1, square root of 2. Okay, so this is your pi over 4 or 45-degree right angle. Trig values. Okay, it is really just that whole chart simplified to 2 triangles. All right, so any questions on that one? All right. Okay. So let's say if we have the example, let's say if we wanted to find the values of the remaining trig functions when given tangent of theta is equal to negative 3 over 4 and cosine of theta is greater than 0. Okay, so we know that if cosine of theta is equal to your x. Okay, so that means that cosine of theta is greater than 0, which is just another fancy way of saying positive, then x is greater than 0. Okay, so that means x is positive. Okay, so if we made a quick sketch, okay, so we know that tangent of theta is positive here. Everything's positive in quadrant 1. And tangent, in quadrant 2, tangent theta is actually negative. Because you have remember that sine over cosine. Cosine is negative, sine is positive. Same thing here. Here you have negative and negative. X is negative and y is negative. So tangent theta will be positive. And here you have a positive x, let me make that there, and a negative y. So tangent theta is negative. Okay? So we know it's negative 3 over 4. So we can cross out that quadrant 1 and quadrant 3. Okay? But they also gave us that x is positive. Okay? So if they gave us x is positive, x is negative in this direction. So when we place x as positive and tangent theta is negative, is in quadrant 4. Since x is only positive in quadrant 4, remember that's where tangent is negative, then we make our right triangle there. Okay? So we figured out we have to make our right triangle in quadrant 4. Okay, so we drew our right triangle in quadrant 4. Okay, that's our theta. Okay, the reason we needed to know which quadrant is because you could have negative 3 over 4 or 3 over negative 4. We had to figure out which one was negative. So we know here, since x is positive and tangent of theta equals sine of theta over cosine of theta, remember that's y over x. So we figured out that our x is positive. So that means our y is negative. So that means it would be negative 3 and 4 here. Y is negative. X is positive. Oops, clean that up just a smidgen. Okay, so now all we have to do is use the Pythagorean theorem and figure out our missing hypotenuse. And once we find our hypotenuse, we can go ahead and just solve for all the other missing trig angles. Okay, so a squared plus b squared equals c squared means you have 4 squared plus negative 3 squared equals c squared. So you have c squared, I just flip that around, that's just a pet peeve of mine, equals 16 plus 9. So c squared equals 25, which means your c is equal to 5. Okay, so we have our missing value of 5 right there. So we have everything we need, now we can just start plugging in values. Okay, so sine of theta, which is opposite over hypotenuse. This is your theta, negative 3 over 5. Okay, our cosine of theta, which is adjacent over hypotenuse, is 5 over 4. Oh, no, sorry, other way around, 4 over 5. And our tangent of theta, which is opposite over adjacent, is negative 3 over 4. Okay, now our cosecant, actually you don't even have to figure it out, you just know you have to flip sine of theta. Negative 5 over 3. Same with our secant. We just know we have to flip cosine, which is 5 over 4. And with tangent of theta, well, for cotangent of theta, we just have to flip tangent, which is negative 4 over 3. All right, so any questions on that one? All right. Okay, so we'll do a story problem. Oh, you want to still write in? All right. Okay, so let's say, for example, a 20-foot ladder leans against a building. So that the angle between the ground and the ladder is 72 degrees. Okay, how high does the ladder have to reach? Well, how high does the ladder reach on the building? Now, with story problems, I always tell people draw a little picture. It helps you so much to visualize it. Okay, so if we have a ladder, let's say this is our ladder. Okay, and that ladder, we know it's 20 feet. And let's say this is our building. Okay, this is our building. A little person in the window, just for fun. All right, so we have our ladder, we have our building, and this is the ground. I'll abbreviate building. Okay, so we have our 20-foot ladder leaning up against the building, and the angle between the ground and the ladder is 72 degrees. So that means this angle here is 72 degrees. Okay, so if we get that and just kind of shift that part out to an actual triangle, we have our 72 degrees here. We already know it's a right angle unless it's a leaning building. And we know our hypotenuse is 20 feet. We don't need the feet, just 20 is enough. Okay, so how high does the ladder reach up the building? Pretty much they just want to know that value, which we'll call that x. And I'll make the x here also. Okay, so we've gone from the actual story problem to a triangle we've worked with before. Okay, so we have our angle, we have our opposite of the angle, and we have our hypotenuse. So since we have our opposite and our hypotenuse, we're going to use sine. Remember, sine of theta is opposite over hypotenuse. So that means sine of 72 degrees equals your opposite, which is x, over your hypotenuse, which is 20. Multiply both sides by 20. You have x equals 20 times sine of 72 degrees. Okay, so x would actually equal 19.02